Hello, welcome. Let's try to solve another Leetcode problem. 3113. Find the number of subarrays where boundary elements are maximum. So we want to find the number of subarrays, and we need to check the length of the nums array. So the length of the nums array is 10 to the power 5. So this means we cannot solve it by using the brute force. Yeah, we must use some other method to solve the problem. So let's just make a drawing. So if we have a drawing like this, so for example, at this position, there's a point which is going to be a number. Maybe this number is 5. And at this position, we have another number, which is also 5. Yeah, and here at this position, we have another number, and which is 5. Yeah, so we just need to count the number of subarrays where the boundary elements are maximum and how many of them if this number is just 5. Yeah. So for example, this 5 to this 5, is this valid? This is not valid because this 5 is not the maximum number from this 5 to this 5 because here we have a maximum number. But what about this 5? So for this 5 to this 5, yeah, as this 5 is the maximum number between this point maybe A to B. Yeah, let's just make this point A and this point B. Yeah. So between A to B, 5 is the maximum boundary element, and this 5 equal to this 5. So this is a valid count. Yeah. So what kind of algorithm we can use to solve this problem easily? So this means in between A to B, all those elements are not useful. If we only want to count this 5 and this 5. Yeah. So this means all those numbers is not useful. So what kind of a data structure we can use to store all those values, but we will exclude such kind of values? Yeah, we can use a stack. We can use a monotonic decreasing stack. So for example, this is 5, maybe here is a 4, 3. So we're gonna store the numbers like 5, 4, 3. It's gonna be a monotonic decreasing stack. So this is some number inside of the stack. And then we have some numbers, maybe 3 or 4, it doesn't matter. Yeah. Now we have another 5. But this is a monotonic decreasing stack, so the number is going to be something like this. We have 5, 4, 3. Yes, such as we don't have that 3, 4. We only have 5. So what are we going to do? Yeah. So we just need to pop out this number 3, and then we're going to pop out this number 4. Yeah. But for this 5, we need also to pop out this number. Yeah. But if we pop out this number, we can still compare this 5 with this 5. If they are equal, that's going to be a valid count. Yeah. So while we are pop out those numbers like 3, 4, 5, we're going to compare the number this 5 here to all those numbers if they are equal. So this means this is a valid count because all those numbers are going to be less than and equal to 5. So this is why this is a valid count. So what kind of data structure we're going to use? It's going to be a monotonic decreasing stack, and if those numbers are equal, we're going to count it. And we still need to use a counter. So here we're going to use a dictionary as our counter. So it's going to be I to 1 for I in range and length of the nums. Yeah. Now we're going to start to count it. So we're going to prepare a stack. Yeah, we're going to prepare an empty stack, so this is okay. Why we're going to set it as 1? Because because for each number, so for example at each position, we're going to set it as 1. Yeah, so for example this is a 3. Yeah, let's just use this example. For example, this is a 5, and we're going to set it as 1. If this 5 equal to this 5, we're going to count it, how many values is this, so it's going to be 1. So this is why we're going to set it as 1. So from here, we have a valid count, so it's going to be 1. And then it's going to be accumulated. Yeah. But let me just start coding, and I'm going to explain it according to the code. So yeah, for the counter, we're going to set it as 1 for each of the number because we're going to count it. Yeah, if they are equal, so for example, this 3 and this 3, they are equal, we're going to count it as 1. This is why we're going to set it as 1. for in in enumerate nums while something inside of the stack, and this number is more than or equal to nums stack -1, because we're gonna put all the index inside of the stack. So we're gonna pop out the index, and we're gonna check, yeah, if nums j equal to nums I, so we're gonna update the counter. So the count I gonna plus equal to count j. Yeah. Finally, we're gonna append the index. So finally, we're gonna return some of the count values. Yeah, so we're gonna set it as 1 because, for example, for a single number like 1, 4, 3, 3, 2, it's gonna also be a valid count. So that is why we're gonna set it as 1 from the beginning. So for example, if this is 3 equal to this is 3, what's gonna happen is this count I gonna plus equal to count j. This means from count I it is 1, 1 plus 1 it's gonna be 2. This means for this person it's gonna be 2. Yeah, so from the beginning everywhere it is 1, right? Now we're gonna update it at this person, so for here it's gonna be updated to 2 and 1. So in total, how many of them? It's gonna be 6, because this one equal to this one. We're gonna update it. This is why we're gonna set it as 1 from the beginning, because this 1 is also a valid count for each of the number. That is why we're gonna set it as 1. And then here it is similar like the dynamic programming. We just need to accumulate the count. So for example, if this one equal to this one, we're gonna accumulate it. It's gonna become 2. So if here is another 3 in between, we have 3, 3, 3. So for here it's gonna be a 3, because 2 gonna plus 1, it's gonna be a 3. Yeah, because this 3 gonna combine with this 3 and itself, so it's gonna become 3. This is why. Yeah. Now let me just run it to check if it works. As you can see, it works, and let me just submit it. As you can see, it passed for all testing cases, and it's pretty fast. And the time complexity is O(n), and the space complexity is O(n) as well. Thanks for watching. See you next time.